Let's begin Chapter 8 on roots, radicals, and root functions. Remember to print out the corresponding lesson pages so that you can follow along as you watch the video and work through the problems. In Section 8.1, Radical Expressions and Graphs, our objectives are to find roots of numbers, find principal roots, graph functions defined by radical expressions, find nth roots of nth powers, and use a calculator to find roots. We know that the square root of 100 is equal to 10 because 10 squared is equal to 100. And we know the square root of 121 is equal to 11 because 11 squared is equal to 121. When you see a radical written in this way without any number in this index location, we know automatically that the index is 2. We just don't write the 2 as an abbreviation. So we're looking for the number raised to the second power that will equal 100, and that number is 10. And then the same thing for the square root of 121. That's the index of 2, meaning we want to find the number raised to the second power that gives you 121. So let's look at the different components of the radical itself. We have the index. The index is going to give you an idea of what power to look for as you're simplifying the radical. We have the radical symbol itself, as well as what's underneath the radical symbol is called the radicand. Everything together with the index, the radical symbol, and the radicand is what we call the radical. All right, let's find roots of numbers. Let's begin with the cubed root of 64. We're searching for the number that when raised to the third power will give you 64. Well, 64 is the same thing as 4 times 4 times 4. So 64 can be written as 4 to the third power. So when simplifying the radical, the cubed root of 64, with an index of 3, we're searching for the number raised to the third power that equals 64. So our answer is 4. Let's find the fourth root of 81. Let's look at how we can write 81, which can be written as 3 times 3 times 3 times 3. So 81 is equal to 3 to the fourth power. So when simplifying the fourth root of 81, you're finding the number that raised to the fourth power will give you 81. And that number is 3. For the fifth root of 100,000, we're looking for the way we write 100,000 as a number raised to the fifth power. So 100,000 is the same thing as 10 times 10 times 10 times 10 times 10. So 100,000 is the same thing as 10 to the fifth power. So we can simplify the fifth root of 100,000 is equal to 10. Finding principal roots, the nth root. Case 1, if n is even, which is the index, and a, the radicand, is positive or 0, then the nth root of a represents the principal nth root of a. And the opposite of the nth root of a represents the negative nth root of a. Here, a cannot equal 0. Case number 2 is if n is even and a is negative, then the nth root of a is not a real number. Imagine you are taking the square root of a negative number, say the square root of negative 4. We say that this is not a real number. The index here, although it's not written, is an even number. The index is 2. So if the radicand is negative, then we could say the even root of a negative number is not a real number. If n is odd, then there is exactly one nth root of a, which is written as the nth root of a. Let's look at these examples. The square root of 25. The square root of 25 is equal to 5 because we can write 25 as 5 squared. The opposite of the square root of 25 is equal to negative 5. Now the fourth root of negative 81 is not a real number because the index is an even number and the radicand is a negative number. So this cannot be a real number. The cubed root of negative 64. Well, because the index is odd, it is possible to get an answer for this. Negative 64 can be written as negative 4 times negative 4 times negative 4. So negative 64 can be written as negative 4 to the third power. So the number raised to the third power that gives you negative 64 is negative 4, and that is a real number. So just keep in mind that if the index is even, the radicand, the number under the radical sign, cannot be negative. If that index is even and the number under the radical is negative, then the result is not a real number. We can simplify square and higher roots using absolute value, meaning the square root of a squared. For any real number a, the square root of a squared is equal to the absolute value of a. In words, a principal square root of a squared is the absolute value of a. Now the meaning of the nth root of a to the n. If n is an even positive integer, then the nth root of a to the n is equal to the absolute value of a. So we're looking at positive values whenever we're taking even roots. If the n is an odd positive integer, so if the index is odd, then the nth root of a to the n is a, meaning we could have positive or negative values when we're taking the odd root of a number raised to the same index power. Let's look at these examples. The square root of 11 squared. The square root of 11 squared, this is an even number, so we're going to have an absolute value answer. So our answer here would be 11. The square root of a negative 11 squared as well. Whenever you have an even root, the square root is going to be an absolute value. So in this case, it would be absolute value of negative 11, which is equal to positive 11. So whenever the index is even, your radical can be simplified as a positive number. The square root of m squared, we can write this as the absolute value of m. And the square root of negative m quantity squared can also be written as the absolute value of m. Whenever you're taking an even root, your answer is going to be an absolute value or positive. Let's look at example 5, the eighth root of negative 5 to the 8th power. The eighth root is an even number, so the principal root is going to be a positive number. This is going to be the absolute value of negative 5, which simplifies to 5. The seventh root of negative 5 to the 7th power, since this is an odd index, then we could have a negative value here. So the answer to the seventh root of negative 5 to the 7th is negative 5. For the opposite of the square root of m to the 6th, our answer is going to be the opposite sign out in front of the square root of m to the 6th simplified. This is an even root, and this is m to the 6th power. We can write this as the negative square root of m to the 3rd power to the 2nd power. And since this index 2 agrees with this power of 2, this can be simplified to negative absolute value of m to the 3rd. The fourth root of m to the 8th, this can be written as, because this is an even index, we're going to have an absolute value here. The fourth root of m to the second, then raised to the fourth power. So that index of 4 and that power of 4 are inverses that can be simplified to m squared, or the absolute value of m squared. But since m squared is always going to be a positive number, we can simplify this as m squared without the absolute value. For these problems, we're going to use a calculator to find roots. Now, depending on what calculator you have, you want to locate the square root, the radical sign, as well as in the nth root sign. On a calculator like this Texas Instrument, the square root sign can be found right here. Notice that it's in blue above the x squared button. And in order to use that button on the calculator, you're going to hit the second button and then the square root and then enter the number. If you're doing an nth root, like a third root, you would type the root first and then use this button. So for like the third root, type in 3 and then second and then this button and then what's under the radical sign. If you're using a calculator like this one, the square root button is located here, and that's for, like, for example, square root of 25, you would hit this button, then 25. For any other root, like a third root or fourth root, you want to use this button, and notice that the symbol is in yellow, so you want to press the shift button before you press that. So like the third root, you would press 3, shift, and then that button and enter the radicand. So just be familiar with the calculator that you're using to evaluate the radicals on this slide. All right, so if you do the square root of 25 using the buttons on the calculator, you will get a positive 5. The cubed root of negative 27, you would press the 3 and then the nth root button followed by negative 27. When you do that, you should get negative 3. If you're not getting those answers using the calculator, please make sure you're able to look at the instruction manual that comes with your calculator, or even send your professor a question and get that straightened out. Because there are some radicals that don't come out as nice whole numbers, and you want to be able to at least get a decimal approximation. And that's what you're going to do for the last two. The square root of 50. The square root of 50, there's not a single number that if you square it gives you 50, so you will get a decimal value here on your calculator. So enter the square root button followed by 50 and equals, and you should get on your calculator, if you round it, you get approximately 7.07. Let's do the negative cubed root of 120. The little squiggly equal sign means it's a decimal approximation. So you're going to type in the negative button followed by 3 and then the index root button and 120, and you should get negative 4.93 when you round it. So practice using your calculator to find roots. Here's an example. When calculating the velocity of a body in elliptical orbit at a distance r from the focus in terms of the semi-major axis A, we encounter the expression the square root of 2 divided by r, where r is a distance from the focus, minus 1 over a, which is the semi-major axis. Let's evaluate this expression when r equals 10,260 and a equals 14,460. Let's use a calculator and plug in what we know. We have 2 divided by r, which is 10,260, minus 1 divided by a, 14,460. And using a calculator, be cautious when you're doing this. You can do this in one step if you put the parentheses in the right place and do the calculations, and you should get a decimal approximation. Let's put a squiggly equals there, and this should be 0.0112. Go ahead and try that on your own calculator to see if you get that result.